Hi there, Internet. It's Mike from QuickNode here, and today I'm going to be interviewing Yannik Schrade, the CEO of Arcium. Arcium allows you to make genuinely private transactions on Solana, and not just sending tokens where people don't know the sender, the recipient, the amount, or the type of token, but also any other kind of transaction on Solana. Think private order books or confidential voting without anyone, including Arcium staff, knowing the secrets. The Solana Cypherpunk hackathon is right now, so it's probably the best time to be learning about this stuff. And also, we'll be following up on this YouTube channel with another tutorial showing you how to build an anchor program that actually uses Arcium to do private transactions. So you probably want to subscribe. Let me check. It's October 2, 3:31 p.m. And yes, QuickNode is still the fastest RPC provider. Let's go.
Thanks for having me.
Yes, excellent. Welcome, Yannick. I want to ask you, how did you get here? I had a peek at your LinkedIn profile. You originally trained as a lawyer for a couple of years.
I got into building when I was quite young, and always was in love with mathematics and physics. But for some reason, after high school, decided that I already knew a lot about computer science and computers. So why not study something entirely different, which was studying law. At some point during studying law, I developed an app for the iPad.
You're a Swift programmer. You don't think that necessarily people who design high quality, beautiful apps for iOS are also filling a whiteboard full of maths, which is generally my experience of cryptographers.
No, I have a multifaceted background. So I was developing that app, which then overnight became super successful, becoming the most sold productivity app in the world.
What did
on the
the
App
app do?
Store. It allowed you to connect your iPad or even iPhone to an external monitor, which wasn't natively supported by
cool,
Apple
excellent.
back then. During COVID especially, that was driving all of the sales because people wanted to work from home, had an iPad, and realized they couldn't do anything with it really.
Which is actually interesting as well, because there's probably like some signals work and some network protocols or something.
I had to hack a lot to get it to work, right? Because Apple had a very limited set of APIs, and there were some unofficial APIs and stuff that I exploited for some reason. Still was allowed to be on the App Store. And so I developed that app. It became successful, and I reevaluated my choice of field and switched to mathematics and computer science. While studying that, I met my co-founders, but especially me and my CTO being really deep into cryptography. And the other guys were into crypto. I wasn't into crypto. So we founded Arcium.
I had a cryptography company myself, and every so often I would hang out on Crypto Stack Exchange. Crypto Stack Exchange is where actual cryptographers hang out, and it's often a very competitive place to people who do anything involving Web3. And so really all I knew is that everyone who really knew their stuff hated everyone in blockchain. They all had stickers on their laptops that said crypto stands for cryptography. They hated that the blockchain people were taking their word away. And I think to a extent that's true. A lot of those people who had those stickers on their laptops are now doing things on blockchain because they realize that there is a huge space to firstly get paid to do research, and they also have a real impact on the world.
I think so too. I think blockchain, this whole space, also what we do at Arcium, is now one of the leading driving forces in cryptography. So if I, for example, look at the work that some of the PhDs in my team have been doing over the years, you can really see that there's always different kinds of industries that are pushing cryptography in some specific. I think for these kinds of operations that we enable with Arcium, encrypted computing, right? Being able to run arbitrary computations over encrypted data without seeing that data. One of the big drivers in the past has been research into how can we do confidential healthcare? How can we do genome sequencing?
It's actually a really applicable problem. Like everyone's talking about training AI data sets, and then people spending enormous amounts on running their own data centers because they don't want to give away the data sets they're using for training to an external company. One of the many things Arcium does is allow a company that has a data set and wants to get an ML model to still use external compute, but have whoever provides that external compute not see the imports for their model.
Exactly. And I think the most powerful property that we enable is not just one party, if you think of AI, that has a data set, but many parties. So we don't even need someone to aggregate all of that data. It could be that there's a DPIN. We're, for example, working together with Dawn. So let's say you have a router in every home and that's tracking some data. And all of this data combined can be utilized to train a model using Arcium, called it encrypted shared state, right? So all of the state is encrypted. The computations we execute are operating over this shared state. You would normally on a blockchain, single shared state, everything remains encrypted. So we don't see the data of any individual, and the outputs themselves can remain encrypted. And so what it means in machine learning, if you think about one of the most applicable use cases is healthcare data. We can have, let's say, 20 hospitals have patient data, and they cannot share any of that data for many reasons. One being regulation. They can now run a collective computation with Arc without ever having to share any data. Yet everyone participating gets a model or doesn't maybe even get a model, just a prediction output. So there's some entirely new design space here opening up everywhere from finance to healthcare.
Yeah, this is effectively allowing people to use external resources without actually sharing unencrypted data, which is amazing.
Yeah.
And if I'm correct, you can have input coming from multiple sources. The inputs remain encrypted. The actual operation of those functions remains encrypted, and the output can be whatever you want. It can be plain text. It can be encrypted with some particular key. It is up to the person running the function to determine.
Exactly. So we remove all trust requirements. And I really think that's not only something that exists in healthcare. I think that exists across sectors.
There are so many cases where somebody really is getting more data than they need to have to be able to give me the output, knowing that something like Arcium exists.
They require zero data with Arcium.
Yeah.
I don't have to share you anything. We can run these computations. You don't see anything.
Yeah.
I think that's key.
Tech, and particularly InfoSec, we've always talked about principle of least privilege. This radically redefines what least privilege is. You should not be able to see the data to be able to operate on it. This is a huge change to like a fundamental assumption of computing. I want to ask, because I first found out about Arcium when you were Elusiv.
Yes.
It was maybe like early 2022.
Because everything on top of Solana, everything on top of a distributed ledger is inherently public by default. If we want to have real-world applications, let's say you want to pay something for a coffee, you want to have privacy. And that's how Elusiv started. We said, okay, we want to offer transactional privacy on top of Solana.
Yeah. It's very funny. I think people talked about with blockchains originally that it was going to usher in this new world of privacy because no one was going to know who your wallet was. When I say who your wallet is, I mean what your wallet address is.
Yeah.
I think of addresses as being like identities. So
I mean,
my address is who I am. My account.
Exactly. I think that's the way you have to think about them, actually.
Yeah. And so it turns out that in many cases, it's relatively easy to work out the real world identity behind a wallet address. And then obviously you can see all those transactions. I mean, I looked at Elusiv back in the day, 2022, for the concept of encrypted transfers of Solana tokens. Can you tell me what Elusiv gave people they didn't have before? And then how your own thinking evolved from ZK to MPC.
Yeah, basically identifying this problem of a lack of privacy, wanting to add privacy. And ZK at that point was the most logical decision. What we were doing basically was building a Zcash on top of Solana, the way you can think of it.
There's something I really like about the idea of bringing privacy to Solana. I've looked at Monero and Zcash. I do love kind of getting private transactions away from these very niche blockchains with very little kind of DeFi activity or anything else on.
None, because they aren't designed for that. But key issue with what we were doing with Elusiv, and we had a lot of happy users, right? But there were a lot of issues with what we were doing with Elusiv. And most of them really boil down to the choice of ZK, of utilizing that as underlying technology. Because as we discussed, how ZK works is I have some secret. In that case, it's my balance and my transaction history, whatever, right? That's something that I keep isolated. It's what I keep to myself. I basically keep that on my device, right? Knowing my balance, same thing. Now, if I want to transact something to you, I generate a zero knowledge proof, and then through some key exchanges, I can send you some funds, anonymous, confidential way, whatever you want, which is nice, but again, leads to this issue that you just described, which is something of a very one-dimensional form of privacy. All I can do is send funds from A to B, and nothing else can happen. And that's greatly constraining what we can do with that, because the goal has to be to have privacy be baked into smart contracts, not just have some A to B transfers. It should be baked into applications. Smart contracts should be able to have privacy. There should be applications that can have privacy, and pair that together with ZK operating in a different execution environments, local clients needing to generate zero knowledge proofs. All of those things combined really leads to a quite bad user experience, which then means nobody uses the tech because it's not unusable, but you have to go out of your way and you can't build apps with it.
Yeah, think of everything you could do on Solana. Imagine the only thing was the token programs transfer instruction handler.
Not just that, you can only do so on the client side, right? So it can only be EOA wallet to EOA wallet. Or no smart contract can that. So can do that. So that's the limitation that we're working with. So that basically means nobody can use it. And privacy is great, right? But privacy isn't great enough for anyone to switch to a worse application. And if privacy will always remain a niche thing and will never go into mainstream. So I think if we say privacy is something valuable that we want to have, then we need to design the systems in a way where we can get this actual adoption. That's one important aspect, I think, that we realized. Another aspect is removing frictions and enabling entirely new forms of applications. So it's not just about having an application A, and application A now has privacy, but instead enabling entirely new applications that weren't possible before. And so that realization of the limitations of the technology, while at the same time we were doing a lot of research into MPC, into secure multi-party computation, then led us to pivot to this greater vision of privacy, which is encrypted computing, encrypted shared state, where we can operate within smart contracts. So on-chain programs can now have private state that nobody knows, can perform any type of private execution within the smart contract. You basically open up new dimensions for privacy.
So for a Solana developer who was building a Solana program that wants to invoke Arcium to do some kind of private computing.
Yes, we basically offer Arcium as this general purpose platform. You can execute anything. What we've specifically designed for accessing Arcium is what we call Arcis, which is our custom Rust compiler, which allows you to just write normal Rust, could be executed by Arcium. In the past, for cryptography, ZK, you always had to learn some new language, normal Rust program. Arcium takes care of compiling it into this cryptographic format, doing optimizations, parallelization, batching, whatever.
I love the idea of meeting programmers where they are right now. I think that's huge. I remember you said it somewhere else, that you're a cryptographer who wants to actually build products. Everyone knows how to write Rust functions. If you're on Solana, you probably should. That's amazing.
I think that is really core. I think, as I said, removing as many friction points as possible. You can always build cool cryptography, cool technology. In most cases, it's incredibly esoteric and niche. We set out to make it go mainstream, right? It was one very important step, I think. That makes it super easy for developers on Solana. Let's say you have some program where you want to have some logic to be executed. Let's say it's an encrypted voting program where users can submit votes that nobody sees the actual vote is, and then you compute over those votes. The actual computation over the votes is just an encrypted function that you specify. Then what happens in execution is that your program calls the Arcium program via CP. Arcium as this dedicated network, which isn't a blockchain, but is this dedicated network, executes and then settles the result back. So you specify what should happen after you get the result. Result can, again, be something encrypted. So in the case of some encrypted vote, where you say, if the vote is this, do that, vote is that, do this, basically you could just add the vote to the corresponding value, right? Arcium would give back an encrypted value and update the account for you. You could also then have a function where you say, okay, now since voting has ended, we want to know what happened, right? So you have a function that reveals those values. Now Arcium will reveal the values. So Arcium won't publish encrypted values back, but public values. So you can play around with all of those things. You say, these arguments that I'm passing are encrypted, the state is encrypted, this output should be encrypted, and this output should be public. So you can really design whatever you want. That's one aspect of what we're doing, but what we are also doing is shipping CSPL, confidential SPL token.
This is great. Just for anyone who wants a bit of a background, if you look at confidential transfers, which was then renamed confidential balances, which is where I send you some amount of the token, people still know it was mine. People still know it was Yannik. People still know it was USDC. They just don't know the amount. So it's a very limited version of privacy. And if you look at your Soulflare and Phantom and Squads, I don't think any of them have support for confidential balances, confidential transfers, because firstly, it's a lot of work to implement it. And secondly, it's a very limited amount of privacy.
And most importantly, since it's CK based, you can only send from my Soulflare wallet to your Soulflare wallet. That's it. I cannot do any DeFi with it. I cannot have a smart contract. And that's one of the key limitations of it.
So it can't even go to a multi-sig wallet?
No, you could theoretically have a multi-sig set up for it. One of the key issues then is, okay, who has the decryption private key to decrypt? What if someone new joins, right? You cannot really have
There's a lot of complexity there.
There's no smart accounts. It's basically a token account bound to a wallet instead of how we normally think about accounts on Solana, right? Which can be any program-derived address controlled by a program. So there's no composability for it. And so what CSPL brings is support for all of those things for the extension itself. So you don't even have to adopt some new token standard by Arcium. We add all of those features.
And this could even be like an existing token from the original token program. Will confidential SPL also work for?
Yes. Basically, what we're adding is you can have confidentiality in every Solana program. Just invoking a transfer instruction with the normal SPL programs, transfer this token of the account that I own to someone else, or even I'm a program and the owner of some account has this transaction. So transact from his token account to some other account. All of that's possible with confidential SPL token without any balances being public. The contract can control user accounts, program-owned accounts, all of those things, from transfers to create accounts, to close accounts, to run arbitrary encrypted computations. We could say, I don't know, if you build a payroll system, which is a great use case for confidentiality, right? Nobody should see how much they're receiving. There isn't really an issue of knowing the identities, right? The most simple form of building a on-chain payroll with our CSPL is you have an instruction where the employer creates a new account for an employee, and instead of publicly specifying how high their salary is, just upload an encrypted amount, then stored. Nobody can decrypt it. Only the employer knows this and the employee. And then every month, the salary should be paid to the employee. There's a function being called in the program, which again calls then token program. And that is a normal transfer instruction. The program transfers the encrypted amount. Program doesn't know the encrypted amount. Nobody knows the encrypted amount. It utilizes Arcium, which also doesn't know the amount, to then transfer to the recipient. And I think payroll is the most simple case. You can build confidential landing. You can build confidential swaps. You can build everything in a confidential way, where you can just support any SPL token, have a canonical confidential representation of that. Yeah.
The other thing that I really like about that, I think there are cases like the payroll example is a common one where it needs to be a smart wallet. It needs to be a multi-sig or something like that. No one's going to have an entire company treasury controlled by one person who has an envelope in their house with 24 words written.
Exactly.
I thought of this for years. The idea of mnemonic passwords, which I guarantee you no one can actually remember, so they're not really that mnemonic, needs to go away, and making sure that things like private transfers actually work on smart wallets is an important step to actually having.
Yeah, I think it's the most important step for bringing adoption. What it boils down to for me really is wanting to enable more powerful applications. I think that's the avenue that we are taking with Arcium, the way we think about privacy, and we always differentiate privacy 1.0 and privacy 2.0. This kind of privacy is privacy 2.0 because we have an on-chain program that can do confidential and encrypted actions without a single human in the world knowing what the underlying information is. And I think that's so powerful because it opens the space for developers to not have to understand anything about the underlying cryptography. We worry about that, rewrite the scientific papers. We build the cryptography that allows you to operate in a trustless way. But as a developer, all you have to understand is privacy on, privacy off, and having functions that execute in a private way, sending tokens around, and being incredibly creative with what you're doing.
It's a well-worn path in terms of when I make a Solana program, I take my Rust and I build it to the eBPF compiler. And there's a Solana operating system that exists. And I imagine the Arcium compiler is just yet another output format for the Rust compiler. Is that correct?
Yeah, exactly.
Excellent. Is it expensive? Is it charged based on compute units? How do people pay for their private functions to be ran on the Arcium network?
It's not expensive. It's fast. It's really based on the complexity of the operation, based on the different opcodes that are being executed, and then also based on how parallelizable is the operation, right? Because things might be more compute intensive, but less, I guess, communication intensive than other tasks. So roughly speaking, It's exactly the same as we know from Solana. And also, you're not then having to work with multiple gas tokens. You just natively pay in Solana. It just increases the SOL price for your transaction, and that's all.
Right now, I'm working on just a little demo app, which is just a proof of funds app. When I was moving apartments, I said I had an investment account, which was a bunch of tokens. They said, oh, could you send us just you logging into the account? Can you show your user your investment account? And what I wanted to do was just make a very simple app, just really showing people how to do things like get prices on chain, to allow somebody to sign something which shows they have tokens worth beyond a certain amount. But of course, what that actually does is reveal the address of their wallet, and it reveals the full extent of their token holdings. So I don't want my real estate agent to be able to see my crypto wallets forever. I only want my real estate agent to know that I have sufficient funds, not the total extent of my personal wealth.
If you were to use CSPL, already have of those tokens, which are currently public. So you switch them to being confidential, which is literally just invoking a single instruction, which turns them confidential.
Is that confidential balances, or is that something that
it's within CSPL, and that utilizes confidential balances, right? So we actually a feature to Solana, which should be live already, to do this canonical switch between the SPL token and the confidential one. So you can switch to have a confidential balance. And then once you have the confidential balance, you can prove that you own some funds.
And the function that runs on Arcium would simply be if the balance is beyond a certain amount. And then and I guess the
attestation would be the signature by Arcium, which is this MPC signature. Or you could have Arcium generate a zero knowledge proof for you, all of those things.
How do developers decide between using zero knowledge or a network like Arcium? Or
I think it mainly boils down to encrypted shared state, right? That's our whole thing, and that's why Privacy 2.0 is, in my opinion, strictly superior, because you can now have interaction between parties. It literally takes me 10 minutes to using Arcium or CSPL, build a program that does confidential lending. With ZK, most of those applications actually are impossible because it's always those isolated secrets. And with Arcium, I can just say, hey, the program runs this computation as it would normally over public data. It doesn't matter that it's encrypted data because Arcium runs that for me, right? So now you can easily switch between public and confidential in the program set. And that's something that otherwise wouldn't be possible. And that's why I think people have also been disillusioned by ZK in that regard. But ZK, I think, a lot of sense for a lot of trust scalability use cases. It's basically a primitive that is used everywhere, right? In Arcium, of course, there's also a lot of ZK being used. Arcium rates output zero knowledge proofs for different things.
So also look at Arcium as being an interface for a lot of tasks they would have done on ZK.
Yes, no, 100%. And in the case of CSPL, Arcium produces all of the proofs that are used in the Token 22 program, right? So all of that is abstracted away. You on the client side don't even have to support proving. Arcium generates that for you within the encrypted computation, which is super nice.
It's amazing. Here's a good question. What would be a good hello world app for people who are new to Arcium, who are already building on Solana, to go and create themselves and do something they wouldn't have been able to do without Arcium?
I think, so in the case of CSPL, I think the most simplification really is payroll lending. We actually then have to think about, okay, who's borrowing something, who's paying for something, how do I compute the values of a public price value?
And what are the inputs and outputs in the case of a payroll example?
In the payroll example for a computation, you wouldn't even have to write a function that is encrypted. You would literally just say, party A submits an encrypted value, which is the salary, and party B claims their salary every epoch or something. And when they claim it, you verify their signature, you take the encrypted value that is stored in the account for that person, and you invoke transfer, and you pass that. That's it. So you wouldn't run your own computation. So that's the most simple hello world, because you wouldn't have to think about writing a custom function. So the next level then would be lending, because for lending, I have to say, okay, how actually manage all of those confidential tokens? Because let's say Mike is lending and I'm borrowing. What if I want to borrow 1,000 USDC, but you only provided 100 USDC into the program? In that case, if at what point do I transfer the collateral, right? So those things makes it more interesting. Also, CSPL isn't live yet. Arcium itself is on testnet, so every developer can just play around with that. But I think there you can really see how it works from this token flow standpoint. If you're talking about encrypted computing in general, right? I think confidential voting really is a good example. Confidential voting actually is something that I think is a very powerful use case.
You talked about this where you have multiple parties actually owning separate inputs.
Yeah, exactly. We are voting about some oracle value that exists in the real world, right? Because one of the issues that these kinds of prediction market oracles are facing as well is if you move away from those few curated markets and open it up for permissionless markets.
Yeah, people are going to create oracles that just, there's five oracles with the one data source or something like that.
Exactly, and how even for those clear markets, I think one of the cases was when Zelensky visits the White House the next time, is he going to wear a suit? And there's this debate. He's not wearing a suit.
Because it was like a black suit. Even without fraud, there needs to be forum.
So Mealy Mark, for example, is utilizing Arcium to do oracle voting encrypted, where you can basically do something like everyone votes encrypted way, votes are revealed, and who voted in a wrong way gets slashed. So you cannot, based on the public information, at least try to move the vote in a specific direction based on how others have voted.
All inputs to that Arcium program.
Yes, and that's a super simple program. You would just say, that's the encrypted value, add it to the yes counter, add it to the no counter, all encrypted.
There's something that I don't quite understand. How do we encrypt the input before it hits Arcium?
On the user side. So basically, you take a public key that's associated with your program. You create an ephemeral ED25519 key. That's also super nice. It literally uses the same curve field as Solana. So on the user side, you encrypt that vote, submit it on chain. Arcium processes that. And the nice thing about confidential voting as a hello world, I guess, is that there is two distinct functions that you need to, which is where you aggregate, basically from the top of my mind, I would do yes and no's. You aggregate those encrypted values in a counter, and then at some point you reveal it, which then means switch from encrypted to public. You literally call .reveal in Arcium, and then that will submit the value. So you would say, is A larger than B, .reveal, and that then would reveal the count. You reveal the individual numbers and do that comparison on chain. Doesn't really matter. But I think that's a good start. And then down the line, you can do things like encrypted order books. You can do encrypted trading, crossing networks. You can do dark pools, all of those things. Basically, the culmination of CSPL and general purpose encrypted computing that we're offering with Arcium is what I'd like to think of as encrypted internet capital markets, where we can now have confidentiality, not just in the sense of me sending something to you, but actual financial system. In TradFi, the majority of the financial system runs in dark pools because your everyday stock is a public ledger. And that has been one of the missing pieces for internet capital markets.
Yeah. The Arcium DevNet is ready now, right?
Yes.
Also, I think it would be really good for us to get together and actually work on a demo app for Arcium. We would love to show Solana developers how to do something real that they wouldn't have been able to build otherwise. And that'd be really fun.
Yeah.
Awesome. Great. Thank you very much, Yannik. Thank you for watching.
Thanks for having me.